All right, welcome. In this video, we're going to be working Calculus BC Review Homework 1A, which is also the multiple choice no calculator section from the released 2008 BC exam, in case that's why you're here. So, for time t greater than or equal to 0, particle moving in the xy plane has velocity vector given by v equals t squared and 5t. Okay, what's the acceleration vector of the particle? Okay, acceleration is the derivative of velocity, and if velocity is a vector, then we take the derivative of that vector by taking the derivative of each of its components. So I know that a is going to equal 2t and 5. Okay, so that means that all three of these are gone. Okay, that doesn't have a y component of 5. These are scalars, and we know that the derivative of a vector is going to be a vector. Okay, so now I'm down to 2. And actually, no, I'm down to 1. Okay, it's b. That one was, not very hard. So, antiderivative of x e to the x squared with respect to x. Okay, remember, if it's not going well for you, you do still have the option, if you can do it within your 2 minutes. I don't want you to spend 5 minutes doing this, but we can take the derivative of the answer choices and see which one of these is going to get us to that. I'm going to do it the way that they, I think, intend for you to do it. I'm like, oh, this is u substitution. So u equals x squared. Du is 2x dx, but I don't have 2x dx, I have 1x dx. So x dx is half of du, just divide both sides by 2 there. And then now I will replace x dx with a half and a du, and I'll take e to the x squared and write that as e to the u. Okay, and we know that'll be 1/2 e to the u plus c. And u was x squared, so we have 1/2 e to the x squared plus c, that's this one. Good, happy. We could also have taken the derivative of this using the chain rule. That would be 1/2 e to the x squared times 2x for the chain rule, which would take care of that half. Okay. The limit as x approaches 0 of sine x cosine x divided by x. Well, I plug this in, and it's going to go to 0 over 0, right? Because sine of 0 is 0, and well, when x is 0, it's going to be 0. So I'm going to use L'Hopital rule. Now, if you're doing this for time, or you're working on this in your real exam, you're not going to write L'Hopital rule. You're just going to do L'Hopital rule on multiple choice. For response, we know we need to justify our answer, and we know how to do that. We know it's going to be the limit as x approaches 0. I'm going to take the derivative of the top. Okay, the derivative of, and this is going to require the product rule, so the derivative of sine x is going to be cosine x. Leave the other cosine the same. Then I'll add, leaving sine x the same, multiplying by the derivative of cosine x, and that's negative sine x. And I'm going to divide by x squared. Oh, this one's a little tricky, right? Now, as x goes to 0, I don't know that I prepared y'all for this. I'm glad this is on this one. Okay, I plug in x equals 0, and I'm going to get 1, 1 plus, oh. Why would I have x squared? I guess I was thinking about the quotient rule. That's very embarrassing. Okay. I was thinking it was going to come back 1 over 0, and then you would know it was non-existent. But the derivative of x is not x squared. The derivative of x with respect to x is 1, and so this limit is 1 times 1, because cosine of 0 is 1, plus 0 times negative 0 divided by 1, and well, that's just going to be 1. Here we go. Consider the series sum from 1 to infinity of e to the n over n factorial. If we apply the ratio test to the series, well, we know what that means. I'm going to take the limit as n approaches infinity of an plus 1 over an. Okay, I'm going to make that happen. E to the n plus 1 divided by n plus 1 factorial, divided by the terms of the original is going to be n factorial in the top and e to the n in the bottom. Okay, from here I'm going to, what am I going to do? I'm going to look at the answer choices and see, yeah, I'm going to need to cancel stuff off. All but 1 powers of that e are going to cancel, so I'll have an e in the numerator. And n factorial divided by n plus 1 factorial, well, that n plus 1 factorial, that's n plus 1, n times n minus 1 all the way down, so it's n plus 1 times n factorial. So that'll just be left with e over n plus 1, and we're taking the limit as n approaches infinity of that, and, well, that's going to be this one. Okay? Implying that the series converges, the limit of the ratio is less than 1. Well, that was true for all of them, but that is what we're looking for. Okay. this converges conditionally versus absolutely was not part of AP Calculus in 2008, but now we know that that means that the series converges absolutely, right, if the ratio test comes back with a ratio less than 1. All right. Now, which of the following gives the length of the path described by the parametric equations x of t and y of t? Okay, we know that for parametrics, our arc length, we're looking for the integral of the square root of x prime of t squared plus y prime of t squared dt. Now, y prime of t, yeah, I think that I'm going to, they both have to be right. And I feel like I could take probably the easier of the two of these and eliminate based on that. Yeah, because all of the x component or x contributions are different, and all of the y contributions are different, except for this e to the 10t both times. Okay, so as long as it doesn't come back that, I think I should be able to deal with that. So if y equals e to the 5t, then that means that dy dt, or y prime of t, or whatever you want to call it, that's going to be e to the 5t multiplied by 5 for the chain rule. So since I have to square that, I'm looking for 25 e to the 5t squared. So it would be 25 and e to the total 10 powers of t. So that's going to be this one right here. It's choice C, because that's the only one I see that's got the 25 e to the 10t. I think if you took the derivative of sine of t cubed with respect to t and then squared it, you would get 9t to the 4th cosine squared t cubed. I see that, yeah, because it would be 3t squared cosine t cubed. Okay. What's the next one? Which of these statements about f are true? Okay, well, I think I can see right now x squared minus 4 is x plus 2, x minus 2. So really what this is x plus 2 when x is not 2, and 1 when x equals 2, okay? Which means that, kind of look at it, it's y equals x plus 2 all the way until x equals 2, and then after x equals 2, but not at x equals 2. Okay, I need to find the y coordinate here, and I think if I plugged in 2, I would get 4. So the y coordinate of this whole is 4. But we know that the actual value of the function is down here at 1. So I've got a picture of it, and I think that should help, right? F has a limit at x equals 2? Yes. F is continuous at x equals 2? No, there's a removable discontinuity. I can't draw this without picking my pencil up off the paper, right? There's a hole in the graph. Okay, no. F is differentiable at x equals 2. No, I can't put a tangent line in here because there's no actual function to lay the tangent line in on. Moreover, if I tried to lay the tangent line in where the function was, I wouldn't have any slope, right? I wouldn't know which way to go. Okay. And so also, we know that if a function is differentiable, then it's continuous. That means if it's not continuous, it doesn't have a chance to be differentiable. So I'm going to say no to that one and choose 1 only. Number 7. Given that y of 1 is negative 3 and dy dx equals 2x plus y, what's the approximation for y of 2? You may have done this problem recently, but I'm going to assume that you haven't. I think this is one that I may have put on the homework for Euler method, especially because it's a released exam. Okay, let's say, all right, I'm going to need, starting at x equals 1, approximating y of 2. Using a step size of 0.5, that means I'm going to be taking 2 steps, each with a step size of 0.5. Okay, I've got my equation for the slope, I've got a point, I'm ready to go. So the first tangent line is going to be, okay, y minus negative 3 equals the slope, which is going to be 2x is 2, plus y is 2 minus 3 is negative 1. Okay, times x minus 1. Okay, then I'm going to plug in my first step. Okay, that's x equaling 1.5. And so that means that y is going to equal negative 3 minus 1.5 minus 1. Okay, so that's, I think, negative 3.5. Okay, so I've got my new point. I'm going to write down my second tangent. Y minus negative 3.5 equals, okay, I'm going to need to get a slope here. Dy dx is 2x plus y. X is 1.5, so that's going to be 3, plus y is going to be 3 minus 3.5 is negative 0.5. And I'll be multiplying by x minus the x coordinate. I'm good. Okay. Now I'm going to plug in my second step. That's going to be where x equals 2. and then y will equal negative 3.5 minus a half of 2 minus 1.5. So it's negative 3.5 minus half of a half, so that's going to be negative 375. All right, here we've got a table problem, and we're going to do a left Riemann sum on the integral from 2 to 13 of f of x dx. Okay, so using 4 subintervals, which will be these 4 subintervals, they are going to take their left endpoint, so I'm going to be using these as my heights of my rectangles. I know that this integral is going to be approximately equal to the width of this interval, 2 to 3, that's 1, times the height is 6, plus my interval went 3 to 5, that's times my representative is negative 2, plus 5 to 8 is a width of 3, and my height is negative 1, plus 8 to 13 is 5, and my height is 3, so I've got 6 minus 4 minus 3 plus 15. Okay. However it's going to take for you to figure out what this number is, you should do that. I think I might take 6 minus 7 is negative 1 plus 15 is 14. Okay, but if you wanted to add to 21 and then subtract 7 and get 14, yeah, it's the same thing. Okay, so over here, the graph of the piecewise linear function f is shown in the figure below. If g is the integral from negative 2 up to x, which of the following values is greatest? All right, so I'm going to draw a little vertical line in here to remind me that this is where I am kind of considering I'm starting my area counting, basically. Okay, so g of negative 3. G of negative 3 is going to be the integral from negative 2 to negative 3 of f, which is going to end up being a negative number because it's going to be the negative of this area. Okay, so I'm just going to write in that it's negative, so I don't think that it's going to be the greatest, right? G of negative 2, that's 0 because it's the integral from negative 2 to negative 2. Okay, G of 0 is positive, but it's just the trapezoid. G of 1 is positive and even bigger than G of 0 because I added on the positive area of this triangle. G of 2 will probably be positive. It'll be the same as G of 0 because whatever I'd added on here gets balanced out over here and subtracted. So it's that smaller positive number, meaning that this one's the greatest. Okay, also f is going to be the derivative of g, and f takes a maximum at x equals 1. So that's going to be a good candidate. Number 10, in the xy plane, what is the slope of the line tangent to the graph of x squared plus xy plus y squared equals 7 at 2, 1? Okay, if I've got x's and y's commingling, I need to take the derivative implicitly. So I'm going to take the derivative of both sides of this equation with respect to x. The derivative of x squared, 2x. The derivative of x times y, that's a product, so I need to use the product rule. So I'm going to take the derivative of x with respect to x, and that's 1, and leave y the same. And then I'm going to add, leaving x the same. I'm going to take the derivative of y with respect to x, and that will be 1 times dy dx. Okay. And then the derivative of a thing squared is 2 times that thing to the first times the derivative of that thing, if applicable. And y is going to have its own derivative with respect to x, so the derivative of y squared is 2y dy dx. And the derivative of 7 with respect to x is 0. Okay. What is the slope of the line? So we're really just solving for dy dx. So I'm going to plug in now with 2 and 1. Rather than solving for dy dx as a fraction, I don't really need to do that, so I'm not going to, right? I'm going to say 2x is 4, plus y is 1, plus 2 dy dx, plus 2y is going to be another 2 dy dx, and that's equal to 0. So 5 plus 4 times dy dx equals 0, meaning dy dx is going to equal negative 5 divided by 4. Okay. Now we're going to let R be the region between the graph of y equals e to the negative 2x and the x-axis for x greater than or equal to 3. Okay. We know what e to the negative 2x looks like. It's, I don't know, some kind of exponential decay. Okay. And maybe this is 3. Okay. And I want this area for x greater than or equal to 3. And also this infinite is another hint that you're going to be running an improper integral. Okay. So we know with an improper integral, we're actually just integrating from 3 to infinity on e to the negative 2x dx. Okay. Now we're going to be able to find an antiderivative for e to the negative 2x, just with a little bit of cleverness. It's going to be e to the negative 2x, but I'm going to need to divide by negative 2 to appease the chain rule. And, you know, anytime I do this, I'm going to recommend that you take 5 seconds to check your antiderivative by taking the derivative. I'm going to take the derivative of this, and half of e to the negative 2x times negative 2 for the chain rule, and that will deal with that and give me 1 e to the negative 2x, which is what I need. So from 3 to infinity, I know I can't just plug in infinity, so I'm going to say that this is the limit as x approaches infinity of negative 1/2 of e to the negative 2x. I might actually call that 1 over e to the 2x minus, and then when I plug in x equals 3, I get negative 1/2 e to the negative 6. I don't need to make that a fraction. Okay. And what else was I thinking here? Oh, yeah, as x goes to infinity, this fraction right here is going to go to 0 because the denominator grows while the numerator is stuck at 1. So I know that goes to 0, and I've just got positive 1/2 e to the negative 6, and that's going to be answer choice A. All right, which of the following series converges for all real numbers x? Okay. So this is one where if we're trying to find the values of x where a series converges, we need to use the ratio test. Okay, but we don't want to do the ratio test on all of these. I'm trying to think. I'll be honest with you, I just like, I know that anytime you've got an n factorial in the denominator, unless you have a factorial in the numerator, it's going to overpower it in the ratio test, and it's always going to come back 0 on that limit. And I'll show you how that works. I know it's D, just from looking at it real quick. I'm not sure if y'all would just know that from just looking at it, if you've done enough ratio tests yet. I think what I'm going to do is I'm going to start off with x to the n over n. Okay, I'm going to do x to the n plus 1 divided by n plus 1 times n over x to the n and take the absolute value. Okay, that's going to go to, okay, all but 1 powers of x are going to cancel, and that's going to be the same way every time. Okay. So I've got x divided by 1 times n over n plus 1. That limit goes to 1, so that's the absolute value of x needs to be less than 1. That's not all real numbers x. Okay, I need something that is going to, as n goes to infinity, not have the same power on top and bottom. I need something that's bigger on bottom. Okay, so n squared, and square root of n, it's going to play out the same way. It's just going to be, for n squared, it would be n squared over n plus 1 squared. For square root of n, it would be square root of n over square root of n plus 1 if I ran this ratio test. So I know that all 3 of these are going to play out the same, and they're going to have a limited interval of convergence. Maybe you already know this, and well, if you know why it's D, just skip. You know, just skip ahead in the video. I'm going to run the ratio test on D and on E. And it turns out that this is valid for B and C. For D, this is the limit as n approaches infinity. I know x to the n plus 1 divided by x to the n is going to end up with the power of x. So oops, yeah. The n factorial is in the denominator, so the n plus 1 would need to also go in the denominator. Okay. This is what would happen after I plugged in an plus 1 divided by an and started simplifying stuff. Okay, I'd have all but one of these powers of e gone, but this would leave me with an n plus 1 in the denominator, and that limit goes to 0 for any value of x, because x is going to be constant. You know, for a fixed value of x, it's going to be constant, but n plus 1 is going to go to infinity, so this is going to go to 0, and that's why it's that one. This one would have an n in the numerator after the canceling, and so that limit would go to infinity, and that would only converge when x equaled 0. All right, yeah, this is better. This is a more typical AP calculus question. All right, so we see this, and it's like, all right, we don't have a quotient rule for anti-differentiation. What we usually do is we hit it with some sort of algebra trick. And so what I'm going to do is I'm just going to distribute a 1 over x. So 1 on the x squared plus 1 will be, well, x squared divided by x is x, and 1 over x. So I'm going to rewrite my integral. Maybe I'll switch up the color. As the integral from 1 to, it looks like e of x plus 1 over x. That makes sense, because that's going to incur a log. So an antiderivative for x is 1/2 x squared. An antiderivative for 1 over x is going to be natural log of the absolute value of x, and we're going to let x run from 1 up to e. So this is 1/2 e squared plus the log of e minus, okay, when I plug in 1, I get a half plus the log of 1. Okay. We have 1/2 x squared minus a half, or 1/2 e squared minus a half. Okay. And, okay, I'm not immediately seeing, well, I think I can definitely throw out this one and this one, because it's just not looking right at all. I see no e's in my denominator, no e's in any denominator. And so I think I will, no, it's one of these three, but like, which one's it going to be? So log of e is the exponent I put on e to get this number e, and that's going to be 1. Okay, minus, okay, over here log of 1 is the exponent I put on e to get this number 1, and I'm going to put the 0 exponent on to get 1, and so that'd be minus just this half. Okay. So 1 minus a half is a half, so this is e to the 2 over 2 plus 1/2, and I could combine these with common denominator. I don't need to write that down. I could say it's going to be this one right here. B, yeah. All right. The polynomial f has selected values of its second derivative f double prime. Which of these statements must be true? Okay, f is increasing on the interval. We don't know anything about f prime. I really don't think that we're going to be able to say that. F is decreasing. Same story. Like, I don't have enough information about f prime to make that determination. F has a local maximum at x equals 1. Probably not. I somehow doubt it. The second derivative is 0. The graph of f has a point of inflection at x equals 1. No, that's not necessarily the case, because the second and third derivatives could both be 0. The graph of f changes concavity in the interval 0 to 2. Yes, definitely, because at x equals 0, it's concave up because of the positivity, and at x equals 2, it's concave down because of the negativity. All right, I was kind of thinking, like, is that true because it has to be a polynomial? But I bet I could think about, oh, yeah, something that's like y equals x to the 4th. That has a 0-second derivative at the origin, but it doesn't have a point of inflection there because, oh, it looks kind of like a parabola. It's just, a little wider at the bottom. F of x equals log of x squared. Take the second derivative, plug in square root of e. Gladly. Okay, let's do that. So we're going to take the first derivative of f. Okay. On the outside, I've got the squaring, so I'm going to deal with that first. 2 times the inside to the first power times the derivative of the inside. And I know the derivative of the inside is the derivative of log x is 1 over x. Okay. Now, if you want to do the product rule on this to get the second derivative, that's fine. I think I'm going to call this 2 log x divided by x, though. Okay. So we can do our quotient rule. F double prime is going to be bottom times the derivative of the top. The derivative of the top is going to be 2 times 1 over x minus the top times the derivative of the bottom divided by the bottom squared. Okay. So if I plug in the square root of e, well, this is just going to be 2 minus 2 times the log of the square root of e divided by the root squared. Okay, and so it's like, oh, right, I know it's a or b. Okay, that's a good thing. I've got it knocked down to 2 answer choices, and if we can get it knocked down to 2 answer choices, we're giving ourselves a good chance to guess right, even if we don't know anything else, right? And the log of the square root of e, what special exponent do I put on e to get the square root of e? That's going to be the 1/2 exponent. So 2 minus 2 halves, 2 minus 1 is 1 divided by e. for all values of x for which this series converges. Oh, we did this one in class, and this one is a little weird, the way this, like algebraically, the way this plays out. So we're going to do the ratio test. Okay, an plus 1 is, oh, wait a second, no. I mean, you could do the ratio test on this, and I'm sure algebraically it would be a little weird. I have caught myself. I don't need to do the ratio test on this one because this is a geometric series, right? It's just a number to the nth power. So I know that this fraction here needs to be between -1 and 1. Okay, now I'm going to multiply all three sides of this inequality by x squared plus 1, and I don't have to worry about the direction of the inequality changing because I multiplied by a negative number, because x squared plus 1 is always positive. So I've got negative x squared minus 1 is less than 2 is less than x squared plus 1. Okay, and this inequality is always true, because if x squared plus 1 is a positive number, then this is multiplied by -1 is going to always be a negative number. So this like isn't telling you anything. Of course, negative x squared minus 1 is always less than 2. It can't not be if x is a real number. So now I've got 2 less than x squared plus 1, x squared greater than 1. Yeah, so that would be if x squared was bigger than 1, then x could be bigger than 1, or x could be more negative than -1. And so it would be these. But at the actual values of 1 and -1, think about what would happen. I'd have 2 over 2 is 1 to the n. Well, the sum of 1 to the n is 1 plus 1 plus 1 plus 1 plus 1 forever, and that's going to go to infinity. Number 17. Okay, f is h of x squared minus 3. We want f prime, and we want to plug in 2. So I'm going to take that in 2 steps. First, I'm going to take f prime of x, and I'm going to take the derivative of the outside while leaving the inside the same, and then multiplying by the derivative of the inside. So x squared minus 3. Okay, then we need to be able to plug in x equals 2. 4 minus 3 is 1, times 2 times 2 is 4, so it's going to be 4h prime of 1. Oh yeah, those are good alternative answer choices. I feel like they're all definitely could potentially trick someone. All right, in the xy plane, the line x plus y equals k is tangent to the graph of y equals x squared plus 3x plus 1. What's the value of k? All right, so if they're giving us the tangent line, then and the k is just like going to give us the intercepts, then we know the slope. Okay, the slope of tangent I'm going to find by solving for y, negative x plus k. I know the slope is right here, it's -1. Okay, so the slope of the tangent, we know also that that represents y prime, and that's going to be y prime equaling -1. Y prime is also equal to 2x plus 3. Okay, so I'm going to find the x value at which it's tangent, and hopefully that will give me the value of k, right? So at the time when y prime equals -1, I've got 2x plus 3 equaling -1. 2x equals -4, x equals -2. -4 plus 3 is -1, yeah. Okay. Now, I can also say that, I can find I think the easiest way to go to find the value of k is just find x plus y, and I can get y by plugging in -2 in for x here. Okay, y equals, if I square -2, I get 4. 3 times -2 is -6, plus 1, that's going to be -1. Okay, so x plus y is going to be -3, and that's k. All right, let's do some partial fractions. So, all right, I can tell you right now it's going to be answer choice A, okay, because there's 2x plus 3 right here. I'm pretty sure, unless something really unexpected is going to happen. I know that they're going to trick people into forgetting the chain rule, so I know within reason it's going to be that one. If you see that coming and you're short on time, that's a good guess. Okay, if you know that, like, oh yeah, that's going to have a chain rule thing going on when I split it off into partial fractions. But we have plenty of time here. This is just homework. So I'm going to say this is equal to a over 2x minus 3 plus b over x plus 2. Okay, and then I'm going to multiply both sides of, I'm going to ignore the integral, right? Both sides of this equation by both of them, both 2x minus 3 and x plus 2, and I'll say that now 7x is equal to a times x plus 2 plus b times 2x minus 3. I choose x equals negative 2. So 7x is negative 14 equals negative 2x is, okay, this will be 0a, plus b times negative 7. Okay, that's promising. That means b equals 2. Okay, and when x is equal to positive 3 divided by 2, I'll have 7x is 21 over 2 equaling 3 halves plus 2. That's not 5 halves. That's going to be 7 halves plus 0b. And that's going to tell me that a is equal to positive 3. So now I'm integrating 3 over 2x minus 3 plus 2 over x plus 2. And this is much easier. This is something we know how to do. Okay. We're going to say, all right, 3 logs of the absolute value of 2x minus 3, but it's like, oh, wait, this inside has a derivative of 2, so I'm going to prepare for that by dividing by 2. That's why it's going to be answer choice A. Plus 2 logs of the absolute value of x plus 2, and I don't have to divide anything here because the derivative of x plus 2 with respect to x is just 1. So I guess I'm dividing by 1. And then plus c, so now it's going to be this answer choice A. All right. What is the sum of the series 1 plus log 2 plus log 2 squared over 2 factorial log 2 to the n over n factorial? Okay, so this is going back to our known Maclaurin series. We know if we see 1 plus x squared over 2 factorial up to x to the n over n factorial, that's equal to e to the x. So it looks like this is equal to e to the x with log 2 plugged in. Okay, so I'm going to say, right, I'm thinking, oh yeah, it's e to the log 2, and that's going to be equal to 2, and I'm going to choose this and move on. Okay. Also, I don't know if we mentioned this in class or not, but the Maclaurin series for e to the x converges for all real x. Okay, you could run the ratio test. If you didn't believe me, you could run the ratio test on the general term, and you could see that it doesn't matter what x is. You're going to have the limit as n approaches infinity of x divided by n, and that's going to be 0 no matter what x is. All right, it's along a straight line. The graph of the particle's position, x, at time t is shown in the graph. Graph has horizontal tangents at t equals 1 and t equals 5, and a point of inflection at t equals 2. When is the velocity of the particle increasing? All right, velocity equals y, or not y, x prime. Okay, so when is the slope increasing? The slope is increasing wherever the graph of x is going to be concave up, right? V is increasing when v prime is greater than 0, and v prime is going to be x double prime is greater than 0. So I'm looking for where it's smiling, which is going to be right up here until the point of inflection. So I'm going to say that's 0 to 2 only. All right. Table above gives values of f, f prime, g, and g prime. Interesting. All right, I don't remember this problem. I wish I'd used it last year. This would have been a really good problem for online. Okay, so this, I think we're going to have to do integration by parts. It's a product, and I'm not going to use UDU, so I must be using UTV, right? There's not going to be some magic antiderivative for FG prime. And they gave us this information, so we must be needing to use that with integration by parts. Okay, what I'm thinking is I'm going to let u equal x f and dv be g prime because I want to have an integral of v, and I think that's how it's going to play out. I'm going to just do u dv. I'm going to let u equal f and dv be g prime of x dx. Okay. Also, I don't have any information about g double prime or the antiderivative of f, so I would not be wanting to let u equal g prime and dv equal f. That's not going to work out for me. So then du is going to be f prime of x dx, and v will be g of x. Okay. Now we know that the integral from a to b of u dv is going to be u times v evaluated from a to b minus the integral from a to b of v du. So we're going to actually plug in on that, and we're going to say that this integral here is equal to u times v, f of x, g of x, from 0 to 1, minus the integral from 0 to 1 of v du. Yes, g of x, f prime of x, dx. We know that's 5, okay, from the statement of the question. Now, what we need to do is say, okay, f of 1 times g of 1, 4 times 3 is 12. F of 0, g of 0 is negative 8. And then we know that this integral here is going to be 5 from up here, the statement of the question. So we've got 20 minus 5 is 15. X sine of 2x. Now this is a multiple choice question that I'm pretty sure I gave you on your most recent unit test, but that's okay. We can do it again. We're going to say, all right, what are we doing here? Oh, sine, yes. Sine of x equals x minus x to the 3 over 3 factorial plus x to the 5 over 5 factorial. I've got faith. We're not going to need to go into and they aren't even, we're not going to distinguish on the general terms. We're not going to do that. I really think that 2 terms is probably going to be enough. Yeah, all of these we could distinguish based on 2 terms, right? Because none of them have identical first 2 terms. Okay, C and E are close, but it's the power of x that's different. So I'm going to actually not include the 3rd term. And when I plug in 2x, I'm going to have 2x here and 2x there. And then when I do x times the sine of 2x, I'll have, these x's in here. And so I'll need to start with 2x squared. So now I know I'm down to these last 2. Then this one, if I take 2x to the 3rd power, I'll have 8x times another x is 8x to the 4 divided by 3 factorial. That's the answer choice E. I'm moving on. All right. Logistic differential equation. Which of the following differential equations for a population P could model the logistic growth shown in the figure in the graph? Okay, this is the solution. This is the S curve. Okay, I don't think that there's much that they're trying to relay to you besides, number one, it's a logistic curve, but you need to believe them when they tell you it's logistic growth. Okay. Second, the carrying capacity is 200. So I think what we're going to want to do is factor each of these and try to figure out which one has that 200 in it. Now, I am going to say it needs to be negative quadratic in P. So because it's dp dt equals number times P times limit minus P. That's just 200, not 2,000. Okay. Meaning, what does that mean? Should I try to figure it out or not? No, I think I'm just going to try to factor it and see which one is it's got to be negative quadratic in P. Okay, these are all positive quadratic in P. So, and if it's going to be 200 and I factor out, 0.001, well, that'll be a 100 or something, or 1,000. I don't know what it is. So it's got to be this one because of the 0.2. Because if I was to distribute this, I'd get a negative P squared. I need to have that negative P squared. These are positive P squareds. Okay. So if I did factor this, I factor out the 1 over 1,000. And the P, and I would be left with, okay, what would I multiply 1 over 1,000 by to get 0.2? Well, that would be 200. And then, well, that would just be a P, because I factored out 1 of the powers of P and the 0.001. Okay, and that's like numerically, that's how they would expect you to do this without a calculator, is that you're supposed to know that 0.001 is 1 over 1,000, and you kind of factor that out and then reconcile with the decimals. Okay, f is differentiable at x equals 2. What is c plus d? All right, well, if it's differentiable, then these two pieces will equal each other, and the two pieces of derivative will equal each other, because it's got to be continuous, and the derivative pieces have to match. So I'm going to start off by saying cx plus d needs to equal x squared minus cx at x equals 2. But then I'm going to take the derivative as well. Maybe I'll do that over here. Okay, the derivative of this is c, and the derivative of this one is 2x minus c. Yeah, that's for the same x values. Okay, now I'm going to need c to equal 2x minus c at the point where x equals 2. So maybe I'll start with that one, plug in over here, and make my job a little easier. Because I've got c equals 4 minus c, so that means c equals 2. Okay, because 4 minus 2 is 2. And then over here I'm going to plug in c equals 2 and x equals 2, so that's going to be 4 plus d equals 2 squared is 4, minus c times x is 2 times 2 is another 4. Yeah, it just didn't look right, but it's right. And so that means that 4 plus d equals 0. D needs to equal negative 4. Negative 4 plus 2 is negative 2. All right, polar curve. Okay, area of a polar curve, we need to remember that that's the integral between two theta values of 1/2 r squared d theta. Okay, that's just a must know. Okay, enclosed by the polar curve, y equals sine squared theta. Ultimately, we don't need to worry about the bounds of integration unless there's something I'm not thinking of. Okay, I'm going to just go as if this is 0 to pi. Traces out the whole thing. Okay, I'm going to just assume that. So it's going to be 1/2 of sine squared squared is 1/2 sine fourth. Okay, I'm going with answer choice C, but I am going to double check that real quick. Yep, that's definitely wrong. Okay, so this one's very tricky. Okay, I will be the first to admit that this one's definitely tricky. And if I was going through this one fast, I might have missed this one. But it looks to me like this is not going to be the answer choice, because I think that this needs to trace out its curve over 0 to 2 pi. And I'll explain my reasoning. Okay. Sine squared theta is always a positive number, right? Because I'm squaring it, right? So I'm not going to have like some sort of, negative r double tracing scenario. Also, I know that, okay, sine of 0 equals 0. Okay? Then in the first quadrant, sine is positive, so I'm going to be going where I expect. Then at pi over 2, sine is 1. Okay, so here I am at pi over 2. Sine squared is still positive all the way through here up to pi, because sine of pi is 0. So this loop here is 0 to pi. So I think it's actually going to be d, is what I'm thinking. But then after pi, like say 7 pi over 6 or whatever, well, sine squared is still positive, so it's going to go in that direction forwards. And so I know that it's going to need to trace out over 0 to 2 pi. I guess because these are symmetric, they're the same area, that's why they gave you the figure, I suppose, and to, I don't know, maybe hint you in the right direction, it's going to be 2 of the integral from 0 to pi of 1/2 sine squared theta squared d theta. So the 2 times 1/2 is going to be the 1 times sine theta to the fourth. Now, the error here is you wanting to. Actually, I know, I'm not sure why. That's you don't know the formula, but you do know that it traces out over 0 to 2 pi. Sounds unlikely to me. Okay, I feel like if you are with it enough on polar to see that that's going to trace out on 0 to 2 pi. You probably also know the formula. All right, number 27. Which of the following could be a slope field for the differential equation dy dx equals y squared minus 1? Okay, this thing depends only on y. So I'm going to be able to knock off answer choices by moving side to side, manipulating x, and seeing different slopes. Because if I do see different slopes when I manipulate x, then dy dx would need to depend on x. Okay, so this is looking like a candidate for sure, because I look side to side and I'm always seeing the same slope. This one's out because, like, just, you know, look at those. We're seeing all sorts of, we're seeing positive, negative, and 0 slopes in one, like, horizontal snapshot. Same for C. Same thing. I'm going side to side. I'm seeing negative, 0, positive, just no. Okay, depends on x. Depends on x. Okay, great. Love those. All right. In the xy plane, a particle moves along the parabola y equals x squared minus x with a constant speed of 2 root 10 units per second. If dx dt is a positive number, what's the value of dy dt when the particle is at the point 2 and 2? Okay, now, this is the first time we've done this, so I'm going to just warn you. Number 28 in general is going to be, you know, the hardest problem on the exam. Okay, it's an hour-long section or so. Used to when it was 28 questions, I think it was 55 minutes. But it's, you know, now it's 30 questions, 60 minutes. The longest section on the test. You know, there's always that one student that is going to race through the test that's going to probably get a bunch of them, you know, most of them right. The test's too easy for them, class too easy for them. And they want to give that person something to think about. They want to challenge that person. They want to challenge every student, right? Just like my class. So they're going to give you a genuinely challenging item at the end. And so, you know, there's no shame in not knowing how to work the number 28 on multiple choice no calculator for AP Calculus. It's going to be hard. All right, so I think that's my disclaimer on that one. The constant speed, okay, dx dt is 0. What's the value of dy dt when the particle is at the point 2 and 2? Think about this. I know that dy dx is equal to dy dt over dx dt, and I think I'm going to work with that. Okay, so dy dx is equal to y prime, oh no, it would be y prime over x prime, but right now I want to say that's equal to 2x minus 1. Okay, and that's going to be also equal to y prime over x prime, and x is equal to 2. So I've got y prime over x prime, off my shot, but y prime over x prime, when x is 2, that will be 4 minus 1 is 3. So y prime equals 3 times x prime. So if dx dt is positive, I know that now that means dy dt is positive because dy dt is 3 times dx dt. And now I need to use that 2 root 10, okay? And really, that's going to help me with finding dy dt. So I'm going to write down the formula for speed. I know that's 2 square root of 10. And that's going to be the square root of x prime squared plus y prime squared. Okay, if you want to just like most directly solve it y prime, you would need to get x prime in terms of y prime and be x prime is a third of y prime and substitute in there. I'm not going to do that because I don't think this is going to be that hard. I'm going to have 2 square root of 10 equaling the square root of x prime squared plus y prime is 3x prime squared. So that's 9 and 1 is 10 times x prime squared square rooted equals 2 square root of 10. So the square root of 10 is going to come from there. That means that x prime is going to have to be 2, meaning y prime is going to be 6. Okay, because 2 squared square rooted, that would be the 2. Square root of 10 is right there. Y prime is 3 times x prime, which is 3. No, pardon me, it was 2. It's right there. So that means it's 6. Okay, but that one was tricky. I generally look at AP Calculus, I know what to do immediately. And this one, I don't know if I've never worked this one before. I haven't worked it in a few years, but this one, I had to sit and think for a second. Like, what am I going to do here? But at the end of the day, these challenging questions, they do all go back to the things that we have to know which is, like formulas for slope of a parametric curve, formula for speed of an object moving along a parametric curve, stuff like that. All right, so that's all. This video with me working it with like detailed explanations and verbal descriptions and everything, I'm still under 50 minutes, and 28 questions, it used to be 55 minutes. So, if you work this yourself, this time without a timer, that's fine. Moving forward, I'm going to ask you to do these problems with a timer and then check your answers against mine. But that's all I got for you for today. Thanks for watching.